Hey everyone, CocoaButterCoder here, aka Coco, and welcome to another episode of the Python Challenge series. So let's hop right into it. Okay, so this is the level that we left off last time, level 2. Let's try to zoom in a little bit. It says recognize the characters. Maybe they are in the book, but maybe they are in the source code. When we opened the source code, we were faced with this big old block of text right here. Um, and what I did was I used a dictionary to put all of the symbols in. The task was to find the rare characters in the mess below. So I used a dictionary to find the frequencies of each of the characters and find the rarest ones. And when you looked at the contents of the dictionary, you ended up with uh, let's see, several characters. I was going to count it out, but you ended up with several characters whose frequency was only one, and they spelled out equality. Okay, so in the source code, and so this is what we ended up with and where we left off. So this says one small letter surrounded by exactly three big bodyguards on each of its sides. So if we go back into the source code for this page, this is what we get with, or this is what we have. We have an image, and that's just the candle image that we see here. One small letter, exactly three big bodyguards on its side, and nothing really else helpful. This is about how to find the solutions to previous problems, but then we're faced with this big old piece of text right here. It goes on for a little bit. Sorry about the sniffling, if you can hear it. I think it's my allergies acting up. So what we're going to do, we're going to copy all of this. Okay, I guess we have to drag. We're going to copy and paste all of this. Keep going, keep going, keep going. It's a lot of text. Take this big block here. And I already have a folder opened or a file open in Visual Studio Code called level3.py. We're just going to call this not test, but text. And we're going to paste this. So immediate problem is that we can't use single quotes. So what we're going to do is we can then try to use double quotes. That's not how you do double quotes. But see, nothing changes, same problem. So then we can move to triple quotes. And now we get what we need. And now we just have to close it appropriately. Okay. So just as a test, if we print this out, we can do, we get the big block of text here. Now the only problem that we have with dealing with this text is it has these new line characters, and that's going to mess it up because what we want is it says one small letter surrounded by exactly three big bodyguards. It's possible that, say, here we have this J on the end, say these were three big letters, and then these were three big letters here, that it wouldn't capture that because of the new line character. So what we're going to do immediately is use regex, and that's what we're going to use for the entire for this entire level. You could write something like a for loop that checks, like, if I guess you could check seven characters at a time and check to see if they match, like big character, big character, big character, little letter, big character, big character, big character, but there's really no reason to do that. And in fact, in Automate the Boring Stuff, there's this interesting uh, part in the regex pattern matching chapter where it says Cory Doctorow. I know some people are fans, some people aren't. I like his books. I think he's a good writer. But he argues that even before teaching programming, we should be teaching regular expressions. Knowing regular expressions can mean the difference between solving a problem in 3 steps and solving it in 3,000. When you're a nerd, you forget that the problems you solve with a couple keystrokes can take other people's days of tedious, error-prone work to slog through. I just thought that was interesting because I know in my discrete mathematics class in university, like they do teach regular expressions and like how to create regular expressions, but then after that, we don't ever really use them. I don't know if that's more on the shoulders of the university for not like integrating like varying classes together, or the responsibility of the student to see corollaries or use cases. That's probably a little bit of both. But in order to avoid these 3,000 steps, and it's not really 3,000 steps, but in order to avoid all of those steps, we're going to use regex. So the first thing we're going to do is we're going to import it. So I got to go to the top, go all the way to the top, and regex. There's a Python package called re. That's the one we need. So we have this text. First thing I'm going to do is format it to address that problem of the new lines. So you can use something like re dot sub, and it says that it returns the string obtained by replacing uh, this leftmost non-overlapping occurrences. You can just ignore that. What it does, or I hope you can ignore it. The way I use it, it just replaces a given pattern with whatever parameter that you put in it. So in our case, we're just going to do sub. Um, I think this R is just for raw rejects. So we're going to replace all of the new line characters with nothing. So an empty string, and that'll glue all these lines together as one. And then you have to input a text or a string to pass, so it's a text. And the sub method returns a string. It doesn't actually alter the string itself. So just reassign that. Now if we print it again, we can see here, just ignore this. Thank you, but no thank you. See if I scroll up a little bit. Try to get to the last one. Yeah, so if we scroll up to the last time we ran it and you like double click, you only get one single line out of the whole bunch. But here, if you double click, you get the entire thing because now it's all one string. So this is great. And now the only thing is now we actually have to solve what the level is asking of us. So what we can do is write a regex. So I'm going to call this sequence regex equals re, and then use the compile. Um, and we need a pattern. So going back into the browser, this is something that I use a lot, regex, or this is the one that I found, regex 101. There are probably others, probably doesn't even matter. And what we actually want this one, the one that's one entire string. So we'll paste that one in. Just to test out the regex. You can also test it out in like Python. Like we could just experiment and just run it in our in interactive mode, or just keep running the script until it works. This is just like a cool little place to try it out until you know that it's going to work. So it says that we need 3 big characters and then one small letter, um, and then 3 big characters, or 3 big bodyguards. So the first thing that stands out to me is that it says one small letter, but it says 3 big bodyguards, and this just might be like an artistic choice. But I wonder if there are like non-character things. So let's see if there's any numbers. It says no matches, so no match on the number, and then here, I guess also checking to see if there's any like symbols. So I'm just gonna do a character class of um, like not. Actually, I could just do uppercase W. Accidentally push E. So any non-word like character, and so there's not. So basically, we know there are no numbers and there are no non-words. So there are just no symbols. These are all letters. Um, so we can use like slash W for everything that follows. It's fine. but the only problem is W is lowercase and uppercase. So what I'm going to do is I'm just going to do explicitly um, like a custom class, I guess, of uppercase, and then three times because it says three big uh, characters, one small letter, and then three big characters. So then we're going to do A to Z lowercase, and then we're going to do A to Z three times uppercase again. Okay, so the big thing here is that like it looks like it's right. It says 527 matches, but there's actually a problem here, and the problem being that um, and this is something that I didn't recognize immediately. It says exactly three bodyguards on each side, and that exactly is very important because you'll notice, like, take this one, just randomly showed up, right? It has three, a lowercase letter, and then three. But there's actually four, five, six on this side, and even more on that. I just don't feel like counting, but even more on this side. So even though it fits, like it matches, it doesn't fit the criteria exactly. Um, so in order to fix that problem, what you actually want is to have a lowercase letter in front and on the end of each, because then it would be exactly three uh, big characters or uppercase characters and then a lowercase character in the middle. So we can do A minus Z on the end here. Let's see, now we go to 184 matches. And then we go A minus C here. And now we have the matches that we need. Okay, so I'm just going to copy this over and go back in Visual Studio Code. And this is going to be the regex that we use. And then one final thing, because we're not done quite yet, but um, it says one small letter surrounded by exactly three big bodyguards on each of its side. And I'm not sure if this is me knowing this ahead of time and saying this, or if there's actually an emphasis here. But there's possibly an emphasis on this one small letter. Like there's an emphasis on this exactly, but it seems like the one small letter is the important part. So I'm just gonna put that in a group, and you can just do that by putting something in parentheses, and now that's in its very own group by itself. Um, and then we're going to do mo, which stands for match object, which is just something. I got the mo from Automate the Boring Stuff from Al Swigert, so that's why I was doing it. But because I had to explain it, I should probably change it. So match object equals re dot find all, just because we know from here that there are 10 matches. And it's probably just best, like you can use search, I guess. Maybe if you only want the first occurrence, uh, or if you already know ahead of time that there's only one occurrence and you're just like, you know, doing the needle in a haystack type of thing. But you wouldn't know that, uh, excuse me, you wouldn't know that before doing this. So maybe using find all is the best option here. So you use re.findAll, put in your pattern. So for us, that's going to be sequence regex, and then we're going to put in our string. So that's just text. And this find all returns a list. So now match object is a list that we can iterate through. So we're going to do for group and match object. We're going to print the group. We can get rid of this print text. We no longer need it. And when we run this, we get LINKED list, so linked list. And so we can try to see if that's what we need to get to the next level. And if we go to linked list.html, it says linked list.php. So let's try that instead. And now we're on to level 4. And that's that. Pretty quick, pretty harmless and painful one. But I think it's pretty cool because I know, like I was trying to say earlier, don't have a lot of experience with Regex before. Like I've used it before, but you kind of just don't, or that's not the way that it's taught or not what many people, I guess, at my level, the university student level, we don't really use it that much. Although there are instances like this when we should, like this whole thing uh, really only took what five, 1, 2, 3, 4, 5 lines of code just to clean up the text and then find what we were looking for. So it's pretty useful, and don't have to deal with problems or logic errors or stuff like this. So this will be our next level for next Wednesday, and this Saturday will be 3 episodes of Cipher Challenge. If you've been following along, Cipher, not the Cipher Challenge, but Cipher Saturday is when I put up a video doing a code or a cipher from Simon Singh's The Code Book. I missed last Saturday due to like personal or family emergency. Um, and so this Saturday, I have the two that I should have had last Saturday because it turned out to be way longer than just one that I thought it was, and a new one. So stay tuned. And thanks for watching. I hope you enjoyed. See ya.